Here we are with another morning of live coding. Today it's supposed to be a relaxing morning. The idea today is to go through sweep through a list of small looking bugs, particularly affecting installing Studio and new application debugger, and just try to fix them so that everybody will be happy and there won't be any hassles when you make an installation. So made a small list of bugs that I'd like to fix, and we'll just do a quick look at what they are, and then we'll dive into them. First of all, when you run Studio, it copies a Smalltalk image into the current directory, and that's problematic because maybe you already had a file with that name that you care about, or maybe you run it several times and the files clobber each other, so it's just a bit messy. So we're just going to find a nicer way to do that doesn't involve clobbering files in the current directory. Then I think I've tracked down a problem. Occasionally, when I'm running a build from the GUI, so the Pharo front end calls out to Nix on the back end, sometimes it hangs, and it doesn't happen very often, but it's a highly non-random pattern. And I think I figured it out now. I think it's when the build process prints a lot of output that it hangs, and I think that probably this is a deadlock where the subprocess is trying to write to its standard output pipe, and the user interface is waiting for the process to terminate. And what needs to happen is the process is blocked on standard out, and it needs to. The UI needs to read from that. So that's the current theory. We'll take a look at that. Next, when I hooked Studio into Travis CI to get some test coverage of running Studio on an Ubuntu trusty environment, there was a build error in building Raptorjet, which surprised me, and I didn't recognize what that is. So we're going to try and whip up an Ubuntu trusty environment and dig into that. And the last thing I'd like to do on Studio, if we have time, is to find a way to have our binary cache approved and trusted. What that means is that when you are running Studio and it wants to install some package that we've created, like the custom packaging of the Smalltalk VM, or to build Raptorjet or something like that, these are packages that can either be built locally on your machine, which takes time, or can be downloaded as binaries off the internet. And the trouble is that normally Nix will only download binaries from one particular known trusted server. And whereas we have our own server and we need to mark that as trusted. So we're going to see if there's a nice way during installation to tell the Nix setup to also trust our server so that we can get binaries and the installation goes a bit more quickly because you don't have to wait on compilations. And then, there's another, I doubt we'll get through all of those things now, but anyway, if we did, the next thing would be to see why there was one unit test failing when I pushed Raptorjet to snab. But let's start at the beginning. So, clobbering these files, Pharo.image and Pharo.changes in the current directory. So the way that this happens is back into our Emacs where we're working. Oops, wrong. That is better. So, sorry, I need to disconnect another one to get the screen back. That's better. So, if we just pull up the relevant code, when we run the GUI, that's the script Studio X11 that runs. It copies the Smalltalk image and changes files out of the Nix store, which is read-only storage, and into the current directory. And the reason that it does that is that the VM wants at least the changes file to be read-write. It's not happy about having a read-only file. It's possible we could make it happy with having a read-only file, and that actually might be a really good thing to do. I'm not quite sure how to do that at the moment, and I want to keep it simple. So the problem I'm actually concerned about now is more that these file names are really generic. So maybe you have a file in your current directory called Pharo.image that you're not going to be happy if it gets overwritten. And also, if you would run this several times with different images, you might get the wrong contents. So I thought maybe as a first step, which maybe isn't ideal, but maybe as a first step, we could just give this a more of a unique name based on this read-only path. So if we look at the path, what it's actually going to be, it's going to be a path like this. So it's going to be /nix/store, and then a SHA-256 hash representing what version of the image it is, and then Studio image. So I was thinking that instead of just saying Pharo.image, why don't we use that as the name, as a reasonable kind of a basic step. I think it's probably okay. So let's do that. So let us say that version is, let's just say the version is the directory name of the image. I think that that is actually okay. And then we would just say this. Not brain surgery, right? Version in the names. I don't know again if this is the optimal solution, but it seems kind of plausible to me. And then I guess the thing is, I think we have some other cases where we do something similar. That's Studio X11. Okay, so if we run the VNC, it'll call that script as well. But we do have one other script down below where we do something similar. That is the test script. So it would be nice to do actually the same thing there as well. So why don't we actually just refactor a little bit, and we'll define a script. Why don't we make a little script that just puts the Pharo image somewhere read-write and prints the name of the image, and then that is something that we could use. So let's say studio a little shell script. The name. So what do we want to do? It'll be a shell script using a well-defined shell, the same we're using for everything, and then we'll do those bits down there. We're going to make this simple and just copy into the current directory, and it would be tempting to use a temporary directory otherwise, and I guess it's a trade-off between making a mess in the current directory versus that maybe actually there's going to be something relevant in here. Maybe we want to save this. Maybe we're going to want to save this and go fishing for something later. So I'm going to err on the side of preserving data. So we're going to copy the file into the current directory. So let's just do that. It's the same as we had down here, actually. That looks okay. We copy it in here, and then we print the name. So the idea of all that is that we don't need to say any of this here. What we will say I guess let's say image is our run shellcode, which will be that. Looks plausible. So we're going to have a variable called image, which we're going to set by running this script which is going to pick a version name based on the SHA-256, copy that into the current directory. So if we run this several times with the same if we run this several times on the same version of the image, they'll still get clobbered, and I'm kind of taking a chance that that's okay. The thing is that with the Pharo Smalltalk environment, you have the image file, which in principle you can save something to. We probably don't need to. You have the changes file, which is where it kind of goes fishing for source code, and then you also have, I think you also these days have changes stored in other places with this tool called Epica. So I can show you what we actually want here. I'm being very approximate, of course, but if we would just pick where we have one of our studio GUIs. So there's a studio GUI. What we would like is if we do a lot of hacking and we lose track of things a little bit and everything, what we want is to be able to come back later and dive into some of these directories, like the code changes, and be able to kind of page through all the stuff that we've been doing in recent times. So this is a little history of kind of all the development we've been doing. That's going back a week. So this is something resembling a Git stash or something like that. So the idea is that all the code changes we've made are actually somewhere and they're accessible. So we can go through here if we need to pick something. So I'm not actually sure where this is stored. I think once upon a time I think it might have been in the changes file, whereas now I think it's actually stored somewhere else. So I don't think that the changes file is that precious. That's the gambit I'm going to take for now anyway. I'm going to chance that we want the changes file to match the image, but we don't have many requirements beyond that. I don't know. This is maybe something we need to iterate on. Let's just get a first step done. Move on to the next thing. Well, I'm not completely satisfied. I mean, the alternative is to just make a temporary copy of this. This will do for now. I got a feeling that it might be better to make a kind of a one-use thing, but I'll need to chat with some proper Pharo gurus about this. We continue on the path that we're already on for now. Okay. Well, why don't we actually just see if that works? We want to. Well, we run the test suite, shall we? Hang on. If we run the test suite, will that call Studio X11? No, and we need to update the test as well. Okay, so then we'll update the test and we'll run that, and if that works, then we'll update the X server. We need to have the same line here. We can remove that and that. Here we're going to say okay. By running our little test case that we hacked yesterday. Next error at line 191. Here we failed to terminate something else. Yes. Distinctly lacking a close quote there, right? No, not there. We're lacking a close quote. Yeah. What we wanted, I think. Semicolon 2, yes, because that was an attribute assignment. Undefined variable version at line 1. Okay, so version. Yeah, it's not actually important. You already get a unique name with the SHA hash, so never mind about that. Okay, so now it ran, we got an error. What does it say? Cannot create regular file. I think that we didn't get, I think that our script to do the copy didn't actually work. So this is the name of our get image script. I'll build. I'm expecting to have that directory populated with our script. Okay, yes. There's the script that our Nix code wrote, and what does it do? Why don't we just run that debug mode like that? Ah, okay. Dir name was the wrong thing, that gave us Nix store. Okay, so I took the dir name of this, which of course was the wrong thing, then it took off the part that we were interested in, and so the part we weren't interested in, what we wanted was this. It's of course the base name. So that might be sufficient to explain the problem. Let's check. We just run our test again. Yeah, it still fails. This is the version of the script that I built this time. Let's run that in debug mode again, see what happens. Now the version looks better. We got a kind of a string that's not going to collide from one version to another. And then so we just echoed the wrong name at the end, is that right? We echoed the dot changes instead of the dot image. Yeah, okay. That was a bug. We should have printed the image name because that's what the Pharo VM wants. By running it again. And it looks like it produced a screenshot. Video test.png. We are still manually inspecting our screenshots for the moment, but I guess we could automate that. What did it look like? Drag it over. So the screenshot thing is something that we did yesterday, right? If you run studio test, then it goes outside the build environment, you know, all the Nix kind of magic sandbox. It goes outside of that and runs in the host environment, the same place that Studio would ordinarily run. It starts the GUI, it instructs the backend to actually get Raptorjit and run a Raptorjit program, and then it visualizes some intermediate code. So it actually runs the application in the same way it would run when you run it interactively as a user, and it makes it do some work, and it makes it render something. And the idea of this was, you know, mostly to shake out any obvious bugs like missing dependencies, libcairo, and all that kind of thing. So anyway, it passed our basic sanity test. So this seems to work. We have files with that name. That file is going to be there, you know, until we manually delete it. So running Studio does make a little bit of a mess in the current directory. We'll get a new one of these each time we refresh the Pharo image, but I think it's a step forward from where we were, because before we were always doing this file and we were overwriting it more often, like because maybe you had a file with that name, much more chance, you know, than this, and from one version to the next. So let's run the VNC GUI as well, which will run the X one, make sure that is actually working too. Because we updated 2 shell scripts, and potentially both of them will be broken. That's interesting. Now it's saying it wants to find Perl, and it's not there. That's new and unexpected. So what we also get when we're on X11. X11 one works. The VNC one doesn't. Looking for Perl of all things. So that seems pretty random, to be honest. Where do we get stash? Is that actually related to the change that we just made now? Or is this something else weird? It's something else and weird. So is Perl being used somewhere? And we don't have it declared as a dependency. But another thing that I did recently is go into the script and I added this pure argument when we run Nix, which hides kind of it purifies the shell environment that the GUI runs in, and that means that in the past maybe some things, some kind of untracked dependencies were creeping into our path, and then with this pure that's at least less likely to happen. And maybe actually Perl is something that we need and didn't have declared. And I'm wondering where we don't see a lot of information there about where that is coming from. Just out of curiosity, if we put Perl here, excellent. Wow, okay, so possible that we actually had quite a few untracked dependencies that were not showing up before. Where is XOR? This is a bit tricky, right? So, of course, my idea with deploying the whole thing with Nix is to avoid exactly these problems, that it works on my computer problem. Because the idea is that we have all of our dependencies precisely specified, we have only those dependencies in the path, and then everything runs the same all the time. And the thing that I overlooked, I suppose, is that that's the way it is in Nix in the build environment, when you build something with Nix. But when you run something with Nix, it's more of a compromise, and actually it normally runs in an environment that is kind of a hybrid between the dependencies you've specified and also the machine you happen to be running on. So the concern there is that I don't have a good test case apparently for making sure that I actually have all of my dependencies declared, and that's a bummer. So it might even be worth taking a look right now to see if we can somehow make the environment more pristine, so that we don't constantly run into this kind of thing. So let's have another look. We've already looked before at the Nix shell man page and see there's something in Nix called a profile. I don't know if we can resolve this right now, but I would really like to, when we run the GUI, to have nothing in our environment except for what we get with I'm trying to think out where we've declared these dependencies as well, because these are runtime dependencies of okay, so again, what I want is for when we start this Nix shell command that we have in our script, where was it? I want this to define the complete environment of all the software that is visible to the GUI and everything that runs as part of Studio. And it really seems like that's not the case right now. It seems like other stuff has been creeping in, and that's not so nice. And I'm not sure why it's breaking at this particular time, but this is of course what happens when your test environment depends on the kind of the machine you're running on. So let's try adding a few more declarations here. We'll take this as a good sign. We'll take the fact that this is breaking seems to mean that we are somehow getting our runtime environment more pristine. Might just be that I haven't tested this VNC endpoint since adding that to pure. Anyway, we'll try to get working now, and we'll consider this to be a step in the right direction. So let's go into Nix packages and just see where we get XOR from. And I normally I don't really like the Nix tools for searching the package repository. Actually, I find them they're slow, and you know, often they give you a name when you want to attribute, or vice versa. So I normally just grep my way around. Oops, one directory too high in that case. I just grep my way around the Git repository where all the packages are defined. So where does xauth come from? Get it with an X server. Can it be the VNC server itself? What about if we put down Tiger VNC here? Is that where the xauth comes from? Because we're running an X server that actually exports a VNC endpoint. And we still don't have xauth. Okay, let's go back in there, look for where. Kind of doesn't seem like we should be needing to install the whole xorg, I really wouldn't think. Unless that's how xVNC works. Right, VNC has xauth, but Tiger VNC perhaps does not. Where is it getting xauth from? And there are a lot of forks of these VNC servers around. I picked Tiger VNC for historical reasons, and it seems to be not having xauth, but perhaps Type VNC does. Where is it getting stuff from? I mean, it seems to be getting a package called xauth. Let's use the normal Nix searching tool. I kind of resent waiting like this because I don't feel like there's anything morally that should be getting computed right now. But look, xorg.xauth. Okay, fine. Let's just add that as a dependency with the right name. In our script, I mean, here we're declaring everything that we want, and we're going to also ask for xorg.xauth. Okay, now it did start, so the VNC server started. It's running the Pharo VM with an X server, and the X server is actually providing this VNC endpoint to us. This is running on Linux. I saw that there was a comment asking about that. So what? Just a little bit of context to explain the runtime environment here. I'm running and typing on a Mac, but the code that we're running here is on another machine called Interlaken, which is a Linux server in my basement. So everything that we see here is on Linux, and the kind of the reason to do the whole VNC dance is because I want to run the GUI on my Mac, or I want to interact with it on my Mac, but I actually want to run it on Linux. Because I think from a development perspective with writing development tools, I really appreciate having Linux as a stable base for all of the kind of development I do. I don't want to be porting things over to the Mac just because, you know, my laptop is a Mac. So what I'm going to do then is hop over to another window here and run a VNC viewer to see what's running on that Linux machine, and we'll see if it looks the way we want it to. Oh, sorry, I got to give it IP address there because I don't have that name defined. And what we get is this, which looks promising. Okay, so that's how the GUI is supposed to look. It's not very pretty. We haven't made it pretty yet, but that's what it's meant to look when it starts. So we'll just run a small program to make sure that everything is as it should be. This is running the Raptorjit virtual machine. Raptorjit is a fork of Luajit. It's running a single empty loop. And when we press this green Go button here, this is the GUI asking Nix to get this done for us. So, I mean, it's using a Nix API to run Raptorjit, which implies that Nix is also responsible for getting the JIT compiler and compiling it and everything. Okay, that worked. We have a profiler results here. And we got a nasty script name there. We might want to fix that. So when we write inline code here, it gets written to a temporary file. That temporary file has a very long name. That's something we can look at later. And this is the way that loop compiled, which we won't dive into now. We'll just say that it appears that the GUI is actually working. So this is a little bit interesting, actually. For whatever reason now, when we try to start the GUI, and when I say whatever reason, I think it's related to this minus pure argument to Nix shell. Even though it had worked fine when I tested it yesterday, now we needed to declare some more things. We needed to have Perl in the path, and we needed to have Xauth in the path, which we hadn't needed to do before. So for now we're gonna interpret this as a good thing. We're gonna imagine that's because we added the pure, and then these things became necessary because previously they were sneaking in as undeclared dependencies from my host machine, and that stopped happening with the pure. So that's the level of sophistication. We're going to dive into that today. The last thing we'll do is just check. We really need tiger VNC there. It doesn't really hurt anything to have it there, but I think that's already being referenced kind of implicitly behind the scenes. Yeah, so it doesn't seem like that's actually needed. We'll skip that. So what have we done? We're on a branch called Pharo image unique name. We have a stash, which was the change that we really wanted to make. Yeah, right. So before we made that digression, we stashed what we had already been doing before. So let's do this separately, shall we? What branches do we have? Nix pure. So we already have a topic branch where we added that pure thing, and I quite like, not to overdo it, but I quite like to keep things on topic branches. So if I see that I screwed up something on a topic branch, even if maybe that branch is merged, I'm pretty happy to hop over there and do the fix there, so that to keep things kind of together. So if somebody else wants to pull changes, they can pick and choose a little bit. Anyway, doesn't matter so much in this case, but that's what we're going to do. We're going to go over to the Nix pure branch. And we'll stash this as well. Yeah, that's okay. We'll pop that stash. And we'll see, what does this look like now? That's the change that we made, that's the change we want. We'll just briefly test it again on this branch. Okay, it's all fine. So we'll commit that. That goes off to GitHub. Then hop back to where we were, which was Pharo image unique name. And we'll merge the git pure. I love merge commits. I realize that other people hate them. I love them. I mean, that's the whole point of Git. And then we will git stash pop. Get back the changes that we had just made to the script. This whole giving the Pharo image a unique name, the kind of thing that we sat down to do in the beginning. Now we have that back. We'll briefly run the test again. And one of the things we did yesterday was do quite a lot of work on getting Travis CI up and running, so that we're not dependent on this interactive testing, that we can just push it and then see what CI says before we merge it. But there's some small late step there that's failing, and that's one of the things on our list that we're coming to soon. So for now, this will do. too short of a comment. Previously, image was copied. This was file with that name, and which can blob at each other when bigger at once. This engine basic compromise of picking a name based on extension path. Fine. And we'll keep track of that with the pull request. We have 2 pull requests to make. And we have an issue to reference, so yeah, issue 64 should be resolved by one of these pull requests. Target that. There's a pull request there. Also target on. Good. We'll make a sweep through later to collect those and merge them onto the next branch, give them some proper testing there, and then once we're happy with them, push them over to the master branch, and then users can always pull something, you know, dependable from the master branch. That's the kind of workflow. Topic branch, aggregate them on the next branch, push them to the master branch when they're known to be good. So back to our to-do list now. We finally got that one fixed, and now we're going to do the Pharo subprocess deadlock thing. So this is probably going to be simple, and we just need to take what we've got and make a simpler, more reproducible test case. So the thing that I think is happening, the theory that we're going to run with, is that in Pharo, when you start a Unix subprocess, if it prints a lot of output, then with certain uses of the subprocess API, you get a deadlock because the process is trying to print a lot of output to its standard out. This is being buffered by the kernel on a pipe, which has probably got something like 64 kilobytes of space or something like that. And when it fills up, then the writes are going to block. So the process can't keep running until someone reads from its standard out. And the GUI is the process that's supposed to be reading from standard out. If it doesn't do that, then we have a problem. So we will we'll think about the right way to do that, actually. So the thing that came to my mind is to use the Smalltalk API to make sure that we're continuously reading, and that probably is the right thing to do, especially if there's an easy way that's already there. But actually an alternative as well, which wouldn't be entirely unreasonable, would be to just redirect everything to a file and let the file kind of pick up all of the buffering. That wouldn't really be the end of the world either. And come to think of it, wonder, because when we run a subprocess, we do it with Nix build, and Nix is already logging all of the output. So it's possible we also just, okay, well, we have a few different approaches we could take. Let's start with the most straightforward one, where we just make the use the subprocess API in a nice way so that we never get a deadlock. And if we have any problems with that, we have a couple of other solutions we can think about. So how do we do it today? We have a class called Nix, and it has some class methods such as build, which takes an expression. So what we do is call Nix build and this calls Nix instantiate and Nix realize. If you're a Nix person, you'll know what this means. So instantiate takes the actual fragment of Nix source code and figures out what needs to get built, and then realize actually builds it. So in both cases, we're calling this command subroutine. We instantiate there. Yeah, so that's... We have a little... We seem to have a little bit of duplication there, actually. So build does instantiate and realize, and the realize actually seems quite to overlap with this command. So that's another thing we should do, is refactor that while we're there, so we don't have two approaches to the same thing. But anyway, I think the issue is here we have this the way that we run the subcommand is we make this pipeable OS process and give it a command. We do a close, which I think closes our closes its input, it closes standard in on it, so that it will never wait for any kind of input from us. It should be able to run to completion, and then we ask for the output and error from that process. So I think what happens is that this method call waits until the process has finished so that it can provide the output, but at the same time, while it's waiting, it's not draining the standard out from the process. So the process deadlocks eventually. It keeps writing to standard out, the pipe gets full, kernel makes those write calls block, and that's going to continue until someone reads from it. So yeah, so the straightforward thing to do here would be to make sure that during this time that we're actually reading. So let's see what this output and error method does. And when I've been browsing around here a little bit in the past, I have seen references to something about deadlocks. So there might be a solution ready. Okay, so self output. That's the first thing it does to get the output. Wait for process completion and answer all available output. So it does a test. Is not yet running, negated, is running. So if it's running and it can provide an output pipe, then we will output on, give us array. Otherwise, we return an empty string. Output on, okay, wait for process completion, writing all available output. Self is complete, while false, wait 50 milliseconds. And then stream all up to. And that kind of looks like, doesn't that kind of look like it's doing what we want it to do? Let's run a little test case so we can see where it hangs. I mean, that kind of looks like a loop that wakes up every 50 milliseconds and reads from the pipe and writes it into a internal buffer in the Smalltalk image, which would be what we want. So let's make this less abstract. Let's do this via the debugger. So that's get a little workspace here, and we will say clear process to be a pipeable OS process. The command will be let's start with just a trivial command. Process close, process output and error. What happens if we run that? Then we get the output was the output of PWD, and the error, so I guess this is standard out and standard error. That's fine. So what I'm thinking happens here is that if we do something that prints like more than 4K or 64K or whatever of output that fills up the pipe, then we get a deadlock. So why don't we just say a We'll do a test now. We'll get just 128 characters of random crap from hex dump. Cat not found. Oh, hex dump not found. Okay, we don't have hex dump. Strings. Will do. We don't have strings either. Okay, we're running in this pure environment. We only have things specifically that we declared, and that we could get other stuff using Nix, but let's just do this in a different way. Let's just run something that generates a lot of output. Hey, let's run. Do we have a charge in? $14K from that. Takes too long. Okay, let's be creative, shall we? We're presumably running in bash. Does that work? So sec. Do we have find? Directory did we do find on before they gave us a satisfying stuff? How big of a thing was that? Give us one string per line. I have to wonder actually if I have also diagnosed the problem properly. So that generated quite a bit of output. This is all the lines of output that we got. We would check. Okay, that was a lot of output. So am I misjudging the problem somehow? That actually printed a lot of output and nothing got stuck. Could it be standard error filling up? When we looked in the Smalltalk code, as I recall, and we saw something that looked actually kind of reasonable. It looked like it was doing the right thing, but was it doing the right thing only on the standard output and not on the standard error? And actually, come to think of it, if we would reproduce the problem, we could just strace to see which file descriptor it's stuck on. But anyway, we'll continue looking as we have been just now. So where do we have it here? We had output and error, wasn't it called? Out. Yeah. Self output. Okay, let's make a test case for that then. I've got a theory that the Smalltalk environment is reading standard out as it should, and the bug is that it's not reading standard error. So if we just change our test case here to write to standard error instead, one of the many ways to do that. Will this deadlock is the question now. How long did it take to run the last time? I don't think it was more than 20 seconds or something. So already at this stage, it's a bit suspicious that it's not finished. I think it's stuck. I think that we've reproduced a hang. We'll do now press the interrupt key. And here we see where we are. So we're in this loop that we saw in the source code where we're trying to do output from the process. We're looping while is complete is false. We're waiting 50 milliseconds and then doing this. And yeah, it's only reading from standard output and not standard error. So and this is like just to vent my spleen ever so slightly. I don't have a nice way to. I'd like to fix this properly in the Smalltalk code and send it upstream and be like a good citizen. The problem I have is that I'm working off the latest release of Pharo. So they make a release every year, and I'm running the latest release that came out, I don't know, 4 or 5 months ago or something. And from the perspective of upstream, this is a hopelessly archaic version. They're not interested in anything, as far as I can tell, that I can send them using this version. And even the tools that you're supposed to use to submit code upstream don't even work, I don't think, on this version. It's some new bleeding edge thing. So a challenge that I have a pending rant about is when upstream projects kind of only support users who are on the absolute bleeding edge version of everything, because application developers like me, we want to be on the stable release and we want to work there, and if we send things upstream and it gets improved, we want to be able to pull that back again on the same stable branch that we're already on. So for me, if upstream project will only work with people who are on the latest bleeding edge release, then they're just excluding a large group of people, including myself, who working with applications and whose priority is to have something stable. So I think that some better workflow is needed. I have my ways to do this on projects when I get to make suggestions. But anyway, that's a roundabout way of saying that I've got a little bit of reluctance to go into this Smalltalk library and fix it, even though it's probably straightforward, because I don't really feel that I can get this upstream, and so it's not that satisfying. So it's kind of tempting, from my perspective, to just redirect standard error to standard out here and be done with it, because we don't really care about keeping them separate in any reason that I can think of right now. So that's what I'm going to do. So if we would take all of that, so what we're talking about then is a workaround, right? We have our, and having had that hang, I just want to check if we run it again the old way, is it going to work, or was that deadlock somehow persistent? Is that just a one-off thing? No, it works. Okay, so that was just a one-off thing. Okay, so now what I want to do is reproduce that problem with Nix, and then I think that we'll just update our little Nix runner to move standard error to standard out, so that we don't exercise that bad case. That's a reasonable compromise for today. But for now, we want to go into the Studio Inspector, run that, which opens our a window that you get presented with at the start. And here we write some Nix code, and now we want to write some Nix code that also prints a lot of output. And we can just say run command. Deadlock test. Now we can actually define our dependencies that we want. We could say native build. Before we didn't have hex dump, but now we could just say that we want hex dump, and Nix will provide that. And we could presumably say hex dump minus c. Input from dev urandom going to head. How many characters do we want? Like a megabyte. Something like that could conceivably work if there is a package called hex dump. No, there's not a package called hex dump. Are we going to search for where hex dump comes from? We will briefly just do that actually. Util Linux. So API of the package. Take something called util Linux. What about that? Any chance of that working? And I guess actually what we want now... This is interesting actually. So we got an error. I have dreadful error reportage, but the way that I deal with it is to just go into the debugger here and click I get the string. See what happened. This is kind of interesting that we got... Is the Smalltalk environment giving us carriage return instead of new line characters? I feel like this is something new that started happening that surprises me. So we don't want... When we ship out a string to run in Nix, we don't want to give it carriage returns. We want to give it new lines. See if we have any pre-baked way to do that. New line. We should just do a text substitution on that string to be sure that we don't funny characters. Where was the method on strings to do replacements? Regex. This is not the fight that we want to have right now. We do want to come back to that. So I'd never noticed this issue before when we had this code here, and it must be the case that the Lua... I'm normally writing Lua code here rather than shell code, and it may be that Lua is equally happy with carriage returns and new lines, and that it is a little bit quirky what we get here, but that it doesn't bother them. I'm just going to take it out for now. To stay fighting on the problem we really wanted to be on. So, got to come back to that though. Now, I'm going to add that to the list. UI sends new lines and so now back here, we're hoping, or we're curious about whether we've got a deadlock. Have we got a deadlock? It kind of seems like it. At least we're in that. We're in that loop to collect output. So either we're deadlocked, or we're actually genuinely waiting for output. I would say we're deadlocked. And I think the thing that probably happens is this script is outputting on standard out, but it's running as part of a Nix build, and Nix is probably treating that as a kind of a status message. So it's probably taking the standard out from that hexdump process and printing it on the standard error of the Nix, and then that's what's causing us to go into this deadlock. So what I would like to try is go into our Nix thingy here, and when we run a build, we will realize I want to say turn it into standard error. Like that. Have a decent shell. So, sorry. That, of course, is what I meant. Take standard error and put it onto standard out, so that if Nix prints something on standard error, we still get it on standard out. Let's see if that resolves this problem. If we run that now, we'll see if we get anything running to completion. So the Nix process, we're sending all its output to standard out. The UI should be reading from the standard out, and we hope then is we successfully get a megabyte of text. But I would have thought it would have finished by now, so let's give it an interrupt and see where we are. Here, go to the updated. So that is still stuck. Okay, we have the PID 10233. See what we can find out about that. Is that what it looks like if you have a blocking right on a pipe? Is that what you would see in strace? I don't immediately know. I don't even have it in my head immediately how to very quickly get a stack trace out of that process. Yeah, you know, this is such a desperate time that we might actually fix the Smalltalk code properly, right? Let's have a look at that. So again, what we think is the problem is that the process is writing to a standard error, and nobody is reading from the standard error because the UI is only reading from standard out, and this is leading to a deadlock. And I would have thought this would have resolved it, but possible that I'm not accounting for the way that redirection really works. I'd be surprised, but anyway, since we had another approach, and this is live coding, and the last thing that we want to do is read the manual live, even if it might be the appropriate thing to do. We will just hop in, and if anybody sees a better track, they can say something in the little real-time comments area. Anyway, back we go. So we were in this function here. When we're waiting for a process to terminate to get its output, when the Pharo Smalltalk is doing that, it waits 50 milliseconds, and then it reads all the available output and puts it on a stream. And we need to do this on standard error as well. So if we get our stack trace back, where were we? We're in realize. This goes to output and error. Goes ask the output and error. That asks for the output of the process, only the output, doesn't say anything about the error there. And then that blocks. Error has been redirected into the thing. Yeah, okay. I mean, I think that's the problem here. We want the output and the error, and it tries to first read the output and then read the error. But when these are pipes, you have to read them both in parallel, because otherwise they will get stuck. So think maybe what we need to do is do something like this little loop. We might have to do this here so that we get both streams at the same time. I guess it would be very nice if we find a way to upstream something like this after we do it, because it's a pity to just locally separate track. So error pipeline. That look. Is an internal, so is that the same as the output? Is an output pipeline? There are a lot of abstractions here, right? Need to connect. So what I would kind of hope is that the standard error and the standard output are treated in exactly the same way. Not immediately clear to me. What is an internal pipe? I tell. First in, first out, stream behavior. Okay, so it's like a pipe, but it's written in Smalltalk. Okay, fine. Error pipeline. One of these virtual pipes. So then, how does that get populated? Go back to where we were. How does that get populated? Error pipeline stream contents. When we ask error pipeline stream contents, it's not obvious to me where that connects with the standard error of the process, right? Where is it happen? So this seems to be just a internal pipe. Seems to be just a pipe object that's not connected with anything. So something somewhere must be populating that. Okay, so where is that reference? Error up to. Also some error. I mean, I'm not that happy about this whole thing. So this is some kind of a this library that we're using to call out the subprocesses is quite fancy on the Smalltalk side. As I understand it, they've kind of written something more or less like Bash. So it's doing all kinds of job control and piping and all kinds of stuff inside Smalltalk. So it's kind of like a part of a very ambitious program, and what I'm trying to do is not ambitious, right? I just want to run a command and get the output. So I'm feeling resistance now to going in and fixing this in the Smalltalk code, because I'm not sure how everything fits together, and I'm not sure if I want to know. I'm gonna do both approaches in parallel. I'm gonna take another little stab at this one for a moment. I'm gonna go back and say that if we can do something cool with Smalltalk here. If we go into the debugger and walk up the stack to where we were, is to this Nix realize, we can edit this code. We'll restart, so we actually unwind the stack back there. That's kind of like throwing and catching an exception interactively. We've said throw away all that processing we were doing, come back up here. And we're going to change this. We're going to put everything into a file, shall we say. And I'm assuming that this is going to run with like bash or some decent shell, because that's necessary to interpret that. So let's see, we restart here. Oops. Right, let's do that again. And we will accept that code, and then we will go back up to here even. Restart this, and we will proceed. And what happens? Do we still get a deadlock now when we're redirecting all of the output to the file? And do we get that file as well, incidentally? Yeah, that's interesting. That's very interesting. I think we've got two deadlocks. We've got a deadlock upon a deadlock now. So I think the first deadlock came when we when we deliberately reproduced the problem. We deliberately ran a Nix build that would generate a lot of output, and Nix would print that to standard error, and then the UI would not read that from standard error, and that would get stuck. And then we tried to do another Nix build afterwards that would put everything on standard out or into a file, and that got stuck as well. And I think it's stuck waiting for the other Nix. The problem now actually is that we have one Nix that's deadlocked waiting on the UI, and that's holding a lock on building this thing here, and possibly doesn't have any timeout or anything like that. So we have cascading deadlocks. And let's just do this the easy way. Nix store realize those are all the ones that we're calling. Some of those have been around for a while. Let's just we can recognize this is the first one that we ran. If we do an strace on that, that's the one that should be deadlock waiting on the UI. And there we actually see it. Cool. This is the original deadlock that we got. So I think when we did the strace before, we did the wrong process. We did a shell that was then calling a subprocess that was running Nix. Now it's the actual Nix process, and what we see is exactly what we hypothesized. It is blocked. It's doing a write, and the write is to file descriptor 2, which is standard error, and it's some hex dump output. So cool. So that's our original deadlock that we reproduced. That is hanging on a full standard error. So we're just going to kill that process now, and then everything should start working like magic. But a little bit more forcefully. Error, okay, fine. We're running this. Error, what was that error? Looking at log now. Now we got the log. Now we got everything logged to a temp file. We're gonna try to put that onto. Okay. Sorry, slowing down for a second. What happened here is we went back over. We just do this again. We got our initial deadlock out of the way, so everything's kind of back in its original position now. And then we ran this build, which generates a large amount of output. And we've got the code set to write all of that out to a file in temp, and that did happen. So this is what Nix did. It said we got to build something, and what the build does is generate a lot of this particular output here, and like, well, really streaming in the window there. Sorry, yeah, so it did a lot of printing out hex dumps and everything, and then after a while it was getting piped into head to just take a certain amount, and then that that errored at the end. So Nix considered an error. So it didn't deadlock, but the end result was an error, which is actually fine. So what I want to do now is we'll make it a bit simpler. We will just write the standard error to the standard out, and we'll imagine that that's sufficient. And then if we would do something like this, we should get an error again, but we don't mind. We don't mind because the error is that Nix code ends in failure. And along the way, we should get the output. Now we get it. Now we're getting the output in standard out, whereas before we got it in standard error. I don't know if this is easy to follow or not, but anyway, we did get all of this output. There's the hex dump. We're seeing what the Nix process printed, and then it abruptly stops, which is actually that's actually okay. So this is looking at another thing, an enhancement that we should do, which is that when you do write Nix code, the errors, now we're looking through the Smalltalk debugger and fishing around to find the string that contains the output from the Nix command, which is of course not what you want. What we want to do is pop up a really nice window that says, hey, Nix failed and the reason is this, and to present all the text. That would be the nice thing to do. That's getting higher up the priority list all the time. But now, I think we actually solved that problem for now, actually. I think, well, we worked around our problem. So we diagnosed the root problem on this. Let's do a little recap, and then we're going to move on. Studio issues. I think we had an issue for this, did we not? UI hangs when running Nix builds with a lot of output. Yeah. So we've been aware that there was a problem of sometimes getting a deadlock when we ran a command. It seemed to happen when there was a lot of output, and now we know specifically that it does seem to be a bug in the Pharo Smalltalk subprocess library, that when it is blocking on this call to get both the contents of standard error and standard output for a process, that it is only draining standard out while it does that. So if the process is doing a lot of writes to standard error, then it will deadlock because the UI is responsible for reading standard error and it's not doing it. So that's a bug in the library, and it would be very nice if we could find a good way to report that. And probably not fix it, right? Because actually that's a pretty elaborate library that's far beyond our needs, actually. So, but it would be nice to find a way to report that. Anyway, for now, we can just take this tiny little bit of code here, take that to the bank, and this should actually be quite nice to prevent this hang from happening to people. So, very tiny, trivial workaround at the end, but this is actually really valuable. So let's do it. Let's export this code. We will, again, we're not really totally at peace with revision control and how to manage the Pharo code in our overall development process. It works, it just doesn't feel like it's quite optimized. You can see what I'm doing here. I tell it that we want to have a repository on disk in the source tree in our git checkout. I can then say, what have we changed compared with that? It says we have changed the method Nix realize. Let's see what we did. We made it redirect standard error to standard out. Fine, and then we can say please save this with an empty log message because we're using git for the actual log messages. Now that's been saved out to disk. Now if we would say now we see this updated on our source tree along with some metadata that we don't care about. And now what we want to do is to commit that. So let's pop onto a topic branch. Here. Well, let's a new branch rather. UI sub no, Emacs this. Why not? Oops, wrong folder. That's in Nix packages. So we got to be really careful. Again, I'm not totally happy with the Smalltalk workflow. So when we add classes and methods, they don't necessarily show up here as unstaged changes. They can also show up here as untracked files. So it's happened a couple of times that I actually, when I'm manually taking the code that we exported from the Smalltalk image and checking into Git, occasionally I've actually screwed that up. which is a pity. And again, then it's very worthwhile we're doing this work on continuous integration to catch those things so that it never gets merged anywhere that somebody would actually pull changes. This looks fine though. So we're going to just stage those files, and we're going to say I'll talk syntax for referring to methods in classes. We work around a bug in the Pharo process to avoid deadlocking on a Nix build that produces a lot of output. The first problem is that Faro is only reading from standard out and not stderr. If we have the strace line, we have that. Fine. And again, we're going to come through on a separate pass and pull up all of these changes and merge them onto an integration branch, test them, and then eventually get them onto master. Okay, 2 down. We might take a 5-minute break, and then we're going to look into why, when we tried installing Studio on Ubuntu, that we got an error when we tried to build something with Raptorjit, which is kind of surprising and interesting, and we'll see what we can figure out about that. Go back 5. Need to restart my streaming software, unfortunately. It has disappeared. So we'll be back in 5 minutes. back we hop. So we were just picking off the next item on our to-do list. Pull that up again. Which is to look into a problem where when we get Studio to run a Raptorjet program and we're on Ubuntu, somehow it's not working, which is surprising again. These are the kind of problems we expect to not have because we're doing everything with Nix. So it's interesting, well, on a meta level that we're having quite a lot of these problems. But anyway, we're going to see what we know about this. I became conscious of this via Travis CI. So when we set up the Travis job to test Studio, we fixed a bunch of things, and this was the last error that it ended up on. So if we find that job, well, we have a pull request to do as well, don't we? Hold on, let's do that just while we're here. That change that we just pushed, we want to make sure that we don't lose track of that. Okay, that's now a pull request. So again, we'll sweep through and clean all those up and integrate them later. Now, we had a branch here where we're adding Travis CI coverage. So why did that fail? Latest test failure there. It came quite far, as I recall. This is running on Ubuntu Trusty. Is it relatively old now? 4 years or something. We go, scroll down, down, down. Down, down, down. It builds the Smalltalk VM and all of that kind of thing. Down, 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 down. We scroll. Still more. Takes a little while. So we're going to want to streamline the installation process. Actually, a lot of what we're scrolling through here is software builds, and another issue we had on the list is to try and get more reuse of that. So there's no point. There's no point actually building the Smalltalk VM, for example, because it's already been built by somebody else for the same platform, Linux x86, x64. So it should actually just fetch a binary, and we need to do some work to make Nix happy to fetch our binaries. Okay, but if we scroll down, and what do we get to? We get to this very, very, very specific thing. This is building the Raptorjet VM, which is a fork of BlueWidget, and it tries to run something called post build VM, and it gets a permission denied error. Okay, so that's weird. So what I want to do now, I can't reproduce, I haven't been able to reproduce that on my NixSource machine, so I want to get an Ubuntu Trusty, and I thought the easiest way to do that, there's so many ways to start a VM these days, but the way that I picked was just to fire one up on Google Compute Engine. So I happen to have a trusty VM here, and I think we're going to try to reproduce that error that we saw in Travis. We're going to try to reproduce that first, and then we might also see, maybe we'll do it in parallel. Do we have tmux? Yes. Oh god, what's the default escape key for tmux? Control B. Will be embarrassing when I don't have my own tmux config. But anyway, so we're going to do two things in parallel. First is we're going to try and run the same test that Travis runs, to reproduce that, and then we're also going to try to just build Raptorjet directly to see if we can reproduce it also in a simpler environment. So we'll start the first one, and that might take a while. So while that runs, then we'll do the other one too. So we have Git. Yes, good. -B. I'll just take it like that for now. Oh, I've already cloned Studio. Okay, fine. Do we get the same error? So that's running our little test case that we defined yesterday, and this was the command that Travis tried to run that ended up getting an obscure error. We'll let that run for a minute. We'll hop over to another window, and we will clone Raptorjet. See if that builds here. It seems we have a reasonably pristine environment anyway, which is nice. We will say make reuse VM, reuse files, then we shouldn't, we don't have GCC. Is there a package with a name something like that? Yeah, it's actually kind of nice that the environment is lacking so much stuff. So when we do the test with Nix, presumably it really is fetching all of the dependencies, even like make and C compiler and everything. Here we are in Nix now. We'll scroll up a little bit in tmux, see if we got the same error that Travis got. Something else. Yeah, we got the same error. So that's good. We got the same error that Travis got. So now we're going to see, before we troubleshoot that here, we're going to hop over here and see if we can reproduce that native toolchain now installed. Will it have a C compiler called CC anyway? Oh, okay, sorry, we haven't done the build essential yet. We've only done the apt-get update. Sorry, we'll install the toolchain from Ubuntu, which may or may not be relevant here, but we'll try it anyway. Well, and actually we could try. Let's not even do that. My Control C isn't working. Hold on. We want to try and reproduce this problem outside the whole studio environment, and then we could actually use Nix here. So Raptorjet defines Nix expressions to build itself, which will use the same version of the toolchain as Studio was using. So actually, if we just run Nix here, that should be the most straightforward way to try and reproduce the problem in a local way. It will still be interesting to see whether we can get the error. We'll parallelize those downloads. If we can also get the error with the native Ubuntu toolchain, because at the moment I don't have a guess about where that error is coming from. Why do we have a permission error on during the VM bootstrapping of the build? Maybe there's a interesting and maybe there's a not very interesting explanation for that. I'm not sure. Here we go. This is building the Raptorjet VM using Nix on an Ubuntu trusty machine, which is basically the same thing that Studio was doing when that failed. Now is the time I wish I'd clicked for a VM with more cores. I'll do that next time. Okay, so that succeeded. So when we just build Raptorjet itself using the Nix toolchain, it succeeds. So it kind of has the look. Well, actually, let's go back and make sure we can still reproduce it over here, because we have actually just installed a build toolchain, which may have had the side effect of making it work. Let's see. So did it work because we did the Nix build directly in Raptorjet rather than in Studio, or did it work because we had installed a toolchain? Looks like we still got an error. Scroll up and check. Same one. Yeah, okay. So we do get this error when we build via Studio, but we don't get it when we build more directly. What about if we build native toolchain? So it might be something to look at the specific packaging that Raptorjet does. Let's do that. Let's look at the way Studio packages Raptorjet. Is it the same version that we're testing? If we go into, sorry, we're in the right directory. Backend Raptorjet. Here is the packaging that Studio uses to get its Raptorjet that it runs when you ask it to do something with Raptorjet. Okay, the first thing we see is that it's fetching it from my private fork on GitHub, and that's because Studio UI is depending on getting a lot of diagnostic information out of the Raptorjet VM, and that's that hasn't merged onto the main line yet, so we should actually be testing this specific version. Get the revision there. Maybe that's the first thing that we can do, is test that version over. Over there. So that's all building fine. So let's see if we would then use the same revision. Try that again. Okay, now we're on the specific revision that we had a problem with. So if we build that, clean, build, will that work now? And if that fails, then it's the replicate version that's the issue. If that succeeds, then it must be something else, so we can go back to looking in. We should parallelize those nodes. So let's just see if there's anything else particularly that we customized in Studio. So we're building with, okay, that's something interesting. We're building with Clang here, and I was using Clang on the main line, but I switched back to GCC. I didn't actually see a lot of Clang. Just seems to be more of a distraction than anything else. So that's potentially an issue. And I guess the other thing we notice is that this is not really importing the standard Repligit. So this is a custom build, so we need to compare that to the way Repligit builds itself. Let's do that. Okay, it looks kind of similar. The main difference being that there we were using LLVM in particular. So I'm editing that on my, not on the machine that we're running on, so we need to keep that in mind. I'm just thinking aloud there that the difference we had is the C compiler toolchain that was used, and that actually seems like it could well be significant given the error that we saw. And what happens now? Got some kind of an error when we ran this. Let's do that again without parallelism, see if it's a bit easier. It builds, but it doesn't run, which is something completely different again on that specific revision. Maybe if we take the latest that branch. Sorry, what commit are we actually on? And we're at the tip of that branch, are we? Sorry, so let's check out that version more specifically. Right now we're on the same branch. What's the problem? And the build is working. It's failing to run. Okay, but now we're going to try. That's on the standard Repligit. So if we would try going over to Studio and switching back to GCC there, just to take kind of extraneous. Take a variable out of the equation because we don't really care about playing here. So if we would just default filer, we don't have to single out GCC. We will just take the normal environment. Hypothetically, would that affect anything at all now when we do the same test again? Expecting this now to take a bit longer because it needs to build Raptorjet. We did get an error. Was it the same error? Yeah, okay. So we still got the same error there, so we can't blame playing for this. It doesn't. Okay, so we've got the problem reproduced. We initially had the problem on Travis. We've now got the problem reproduced when we run Studio on a VM that's running Ubuntu Trusty, which was on Travis. So we've reproduced the problem, but we haven't managed to minimize it because we tried then to come over here and build Raptorjet. So, okay, another difference is the Nix packages collection. So these are maintained independently for the Raptorjet has a particular pin set of Nix packages that it uses by default when it builds, and Studio also has one, and these are not necessarily the same. So if we look at on Raptorjet, it's that specific version of the Nix packages that we're pinned on. So how about on Studio? That looks like the same version, doesn't it? 6B, B4DE. No, it's not the same version. Okay. So what about if we try then doing our Raptorjet build using exactly the same pinned packages as what we have on Studio. So now what we're trying to do is use the same version of GCC and make and anything else, you know, obj dump, elf utils, anything else that's accessed during the build should now be building with the same versions that we use in Studio. And if this is a problem, then it will be really interesting actually. Then it will be one of those cases where a dependency somewhere far away has gone wrong and we want to know why, and we need to figure out how to apply our Nix Git bisecting workflow here. Because the great thing about Nix that I've done once before that I blogged about, but I don't think I've live coded one of those yet. But when you update like a new version of the distro and something breaks, you can use Git bisect to identify the exact packaging change anywhere that actually caused the problem, which is fantastic. So if that's the problem, it'll be a great demo that we can do. First, let's make sure that this gets parallelized with all of its downloads. So what we want to see happen here really, ideally, is the same error that we saw on the other window where we get this permission denied during the build of the VM. That's what we want to see. Something that's crept in somewhere where we're hypothesizing that it might have crept in with an update to the Nix packages collection. It's still odd that it only affects us on Ubuntu, and you've got to wonder if I don't immediately know how to account for it only triggering on Ubuntu again, because with Nix we are trying not. We shouldn't be referencing anything. So maybe the Raptorjet make file could possibly be going out to /user or something and looking for something specific, doing something naughty. There might be some impurity there, which would. Well, I don't know. I don't know what the case is. But this actually looks like it's working, because I think it's that build VM step that should have been failing. So it looks like that is actually still working. So it looks kind of like there's a test suite failure, which is odd. But the build succeeded, so at least we didn't reproduce the problem that we were looking for. Might have found something else to come back to. Software requires an awful lot of maintenance. It's something I've noticed in my life. Anyway, so what we wanted, this is back on the studio side. What we wanted to see was this. So we should have seen this host cc, host link, and then build VM. So do we see any of that? Yeah. Host link build VM, so it creates its host / build VM and then it runs it, and that's fine. So somehow when we do that over here, we got an error. Okay, so we're only going to do a little bit more because it's nearly lunchtime. But what about if we just try and get a little bit more verbose debug information out of that? But it's still a little bit fascinating. You know, actually, let's see if we can reproduce it in a smaller way with Studio. So the way that we're running it with Studio now is actually running the GUI and driving everything through the GUI. So what about if we would try directly on the API? It would be interesting to know if that also fails. So if we would just write Nix build, ask it to build Raptorjet.run. I wonder if we could just on the command line ask the backend build something for us. Now it's trying to build Raptorjet. And now it worked. Jesus. It's when we run the build through the GUI that it fails, apparently. Whereas when we do it just directly towards the back end, it succeeds. So what do we do differently? Look again. How we run things on the Smalltalk code. We do a separate instantiate and realize. I wonder if that can be relevant. What about if we try doing it that way here? Okay. So we do the instantiate, then we ask it to realize. The instantiate has run the Nix code to figure out what needs to be built. Now we're going to ask it to actually build. Is there any difference there? No, I mean it's already got to the point that was supposed to be failing. Is there anything else we do differently? Realize, Nix store minus realize, derivation, same. Instantiate is also this is actually a little bit mysterious. So we've learned a lot by the way it's been so. You know, one last thing I want to try. One of the last things. We declare our dependencies in here, and one of them is Nix. I said use the unstable version of Nix for the GUI. So we're actually running potentially a bleeding edge version of Nix there. I wonder if I would take that away. Sorry, I'm on the wrong machine now. If I would take that away, could that be the reason? Could it be the version of Nix that we're using that somehow is relevant here? Especially that we're referencing an unstable version. Let's try going to the normal Nix there. And now we want to run the GUI and see if we still get the error. And it looks like we still have the error. Yeah, okay, so it doesn't seem to have been that. So somehow, when we see anything more specific in the log here either. Building, this is also kind of interesting. So we can see the GUI is specifically building this derivation. So we can also reference that directly. See if we can get out of a. We can also reference that directly from the command line. Yeah, we're not able to do that. It got rid of the derivation when it failed. I only want to give it a little. I'm reluctant to give up right now, although it is kind of lunchtime. But what I'm going to do is, for the first time, actually try hacking the Smalltalk code, not the Smalltalk environment, because I just want to add a little bit of more debug information on the way that it runs Nix, and we need to do it in the GUI because that's where the only place that we can reproduce the error. Actually, if we go into front-end code, and if we go specifically into the Studio Nix package, now we're poking around with the on-disk representation of the Smalltalk code. Pretty thing. So in the Nix class, we want to find a class method called realize. And when we run nixstore -realize, we want to also give -k, I think. Keep failed builds. Okay, small k is keep going, big K, keep failed builds. So we want to put a nice big K there. And now we run bin/studio test. What we expect to happen is that Nix will realize that we'll do the SHA-256 hash of all that Smalltalk code. It'll see that it's different. It'll bootstrap the image again, which it's actually doing now, which is kind of neat. So if we edit any of the code in our checkout, including the Smalltalk code, it should all get pulled in. So now, when we get the error again, Nix should have left some more debugging information on disk. It should not have cleaned up some failed things. Let's see if that is really the case or not. Keeping build directory here. That's nice. Okay, so that is the directory where it was doing the build. So now we should be able to if we go into that directory, we should be able to source the environment. This is a very funny looking prompt. I'll put it back as it was actually. Something. Oh no, we were just in a funny directory name. Okay, so we were in here. We should be, because we sourced that environment variables thing, we should be running with all in the same environment that the Nix build was doing. Aha, so now we reproduce the error interactively. Sorry, and I'm going to strip down this prompt a bit. Say that that's enough. We've actually got it reproduced now. So now we've gone to great extreme Nixy lengths to get ourselves into the specific build environment that was failing when everything was run through the GUI. So we're in there now, and we could like look at these files now. We could say we're in the specific build environment, so that actually also limits what we can do. So we might want to hop into another shell. Also in this, let's also inspect this directory using another shell that has more software available. Go into a new shell, hop in there, and let's see what kind of file build VM is. It's an elf executable. Has execute permission. And it gets the permission denied anyway. So that's kind of interesting, right? So wow, we're actually getting really close to the root of this thing now. We've got a file. It is an elf executable, and we get a permission denied when it runs. So what do we know about this? Not a dynamic executable, but let's strace it. See if that sheds any light on anything. So the execve system call is giving us a permission denied. So when the shell asks the kernel to run, or when strace asks the kernel to run that, when we try to run that program, the kernel refuses to run it because of a permission denied issue. So why the hell is that? Again, an elf executable has the execute bit set. It looks totally fine. I mean, if we copy it into /temp, try to run it from there, then it works. So if we copy the exact same binary to a new location, then it works. So there's something magical about that inode. Like what is magical about this? This is more surprising than what I was expecting to find anyway. So let's poke this ever so slightly more. Let's hop into that directory. Where were we? It was in source host. Again, if we run build VM, permission denied. It's the exec vi. If we run it like that. Okay, can't do it like that. The new shell doesn't help. If we just copy it, keep it in the same directory, we just call it x, then it doesn't work. Okay, that's more interesting. So we copied into /temp and it worked. But here it didn't work. And so it can't run on this file system or what? Where are we? We're in /run /user /ddddd. This is where you would have anything in the kernel log, perchance? No. Fascinating. So why? Let's try another couple of variations, right? If I copy it up into the parent directory, that's no good. What about grandparent directory? That's no good. Great grandparent directory. Copy it up there. Copy it into the great grandparent directory. Can't run there either. But if we copy it into /temp, it worked. I find this just hilarious. Again, copying into /temp works fine. We give it name X as well. Is that a problem? Temp X, you know, that is fine. So what file systems do we have? So now we're somewhere on /run, /user /diddly. So we've tried running it from /run where it doesn't work, and from /temp where it does work. What about, we have a home directory? Yes. If we copy it to a home directory, then it works. So it kind of seems to be something specific about this. Something specific about this file system that we're on. /run/user. How is that mounted? Noexec. I mean, can we run anything on this file system? Let's write a shell script. S.shell. Okay. My preliminary conclusion is that Nix, for whatever reason, is trying to build in this run user blah 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 directory, and on Ubuntu Trusty, that is mounted on a file system that is not allowed to execute anything. So, I mean, part of the VM bootstrapping is that it generates a program and then it runs that very program in order to generate some code. And in this scenario, that would not be supported. That seems okay. And this is something that happened when we tried to drive the build through the GUI, and it didn't happen otherwise. And we can't immediately account for that either. I don't see why the user or the file system should be different. But anyway, we just summarize what we figured out. And I'm going to break for lunch. When we try and build RaptorJIT through the Studio GUI, the build happens in run user 1001, or on the run user file system, and the build involves compiling a program called build VM and then running that. This is a bootstrapping step in the VM. It wants to do some generate a program that's going to generate some code that the VM depends on, which doesn't seem that strange to me. And this fails because the file system mount options does not allow anything on that file system to execute. And a bit of a mystery is why this mismatch. Why is Nix trying to run the build on a file system that doesn't allow things to execute? And the other question is, why is this only happening when we run via the GUI? When we just directly try to run RaptorJIT from the command line in the other shell, why did that work perfectly fine? So that is something to figure out. Wow, this has all been a bit more interesting than I expected when I sat down to do some just pedestrian debugging. I thought it would be a couple of trivial things. We had some kind of interesting deadlock. I mean, a sufficiently exotic case that people who had written a very elaborate Smalltalk process management library apparently overlooked, which was, means it's a little bit unusual and surprising. And then we also had this kind of much funkier than expected thing. And when we fix this, then we're going to have CI working as well, because again, this is the error that we see on Travis CI. This is what's preventing our continuous integration green light from coming up. So this will actually be really, really satisfying to fix, and it looks like we're getting close, and it's a problem worthy of our consideration. So having said all that, I'm going to say thank you very much for joining me on this little debugging spree, and let's do this again later. Thank you very much.